All right, welcome to the third video in the series where we're walking through the process of building a system to design custom crown forms. Now, last video we had got to the point where we 3D printed this specific crown form. This is a reproduction of a vintage crown form. In this next video, we're going to talk about how we make the tipper. The tipper is a piece, it's essentially a mirror of the top that fits in like this, and it has a small gap to accommodate the felt. But the idea is when we're making a hat, we pull the felt down over this. It's going to be tight across this crown form, but what we actually want is we want to capture this concavity here, and in order to do that we would have this form here pressing down, and then we would put a weight on top of this. All right, that's one method when the brim is going downwards, as it is in this one, but in some cases the brim is actually curved up, and if you have an open brim form, then the crown would actually be aimed going downward like this. And that's also why we put these tooling holes in the tipper, because we want it to be centered and oriented correctly relative to the brim frame. So this would end up going on some posts at the base, and then our crown form would then sit directly on top of this, and then everything would be centered and lined up, so you won't get any misalignment. Okay, so that's what the tipper is, and what we're going to do is we're going to make a tipper for our newest crown form, and we're going to start that by going back into the Rhino file that we used to build this one. All right, so that's the next step. All right, we're back in Rhino, and this is where we left off in the last video with our crown with the holes. Now I've added some additional layers here to our default template, and these additional layers are going to be for our tipper, and we're going to start with an offset. So I'm going to turn this layer on, and the layer that we're going to offset is not the layer with the holes, but we're going to offset the layer, the trim form. Now the reason is that the hole layer, if we look at it, it's going to have some complicated geometry down here in the bottom, and we don't necessarily want when we do the offset, that could complicate the mesh, and we're not really interested in the bottom. The tipper is going to be based on this top piece, so we're not going to offset that one, but we are going to offset this layer. All right, so what we do is go to the command line, offset surface, hit enter. It's going to say select the surface, and then hit enter. We selected the crown, and then it's going to say a distance. We're going to do 2.5 millimeters, which is essentially 1/10 of an inch, and we want the corners to be round, and we want this to be solid. We're going to do a tolerance of 0.01. Here's a key piece. It says select object to flip direction. Now if this were pointed the opposite way, we would click the object and it would reverse the direction. It's kind of confusing, but it's exactly what it says, but we don't want it that direction. We want it pointed outwards. All right, so if you ever get in a position if you're using this command and then the arrows are going the wrong way, you want to figure out how to get it the other direction, this is how you do it. Doing negative distance isn't going to work. All right, we've got it the way we want it. We hit enter. Get the beach ball because it's doing something. complex the surface is, the longer it takes. All right, so that's our offset. And if we look at our layers, we'll notice that it actually put the offset on the correct layer, because that's where it was created. All right, that's the offset. All right, the next step is what I have, the layer here I have labeled cylinder blank. And I have these layers labeled, in order in terms of this sequence of the process we're doing. So the cylinder blank looks like this. This is part of the default template. And so this cylinder will already be in here. If you're doing it from scratch, I will explain what I did is when I click this, it's asking me for a curve or an extrusion. So what I did was I drew a circle that encompasses the crown. Move this out of the way. I did a circle that encompasses the crown, and then I extruded it into a block that basically goes up to 140 millimeters. So this is going to be our standard sort of dimension for our crown to the bottom of the tipper. This is important when you invert it and you're putting it into the tipper frame. You want it to all be the same height. That way you don't have to change or modify the frame height every time you do a different crown. All right, anyway, currently if you're using the template, this will already exist in the template, this cylinder. And what we want to do is we want to do a subtraction of the crown from this cylinder block in order to give us the basic shape of our tipper. All right, and we do that by doing a Boolean difference. And it says the surface we're going to subtract from, we're subtracting from our cylinder block. And we hit enter, and the surface we're going to subtract with is the crown. Hit enter, and now it gave us this purple piece, which is essentially the cylinder block minus the crown. All right, now you notice it's still on the cylinder blank layer. So what we want to do is we want to move it to where we have our Boolean difference layer. And we're going to select not the extrusion, but the poly surface, properties, move this to the Boolean difference layer. And then when we do this one layer on, we're just the Boolean difference layer. Now we have just this object, which is basically it's like an imprint, a reverse imprint of what the crown is, an offset version of the crown. All right, one thing I may have forgotten to mention is why are we doing an offset? Why are we doing an offset from the actual crown? This distance, this 1/10 of an inch distance, is essentially roughly the thickness of the felt that you're going to be using. And so when we make our tipper and our crown, there's a 1/10 of an inch difference there that accounts for the thickness of the felt. So if you knew you're going to be using something that was thinner or thicker than that, then you may want to change that offset distance. But a lot of the felts that I'm using, or that I think that a lot of people are using, are going to be roughly a 1/10 of an inch, and it doesn't have to be perfect, but that 1/10 of an inch offset is essentially accounting for the thickness of the felt. All right, now we're going to go to the next step, which is where we cut this to the shape we want it. All right, so we want to be working with this layer currently. And here's where this requires a little bit of some drawing skills. But don't be too worried, because we can do an initial drawing of where we want this the shape of the tipper, and then if we don't like it, we can change it point by point. But what we want to do is we want to make the cut surface our primary surface, and then we're going to be working from the top view. but you want to keep an eye on these other views as we draw our lines. What we're trying to do here is we want to draw a line that is roughly at the tip of the crown here, the very tip. This is going to be the edge of the tipper, so we want it just to the inside of that upper edge. If it goes too far, it's going to create like a little crease line, which we don't want. So we want it just as this, almost like tangent to this line here, where it starts to separate here. We're going to draw a line, or basically an oval in this case, around this upper edge. All right, and the command for that, we go to the command, and it's going to be interpolated curve. Interp curve. All right, we're going to check these boxes too: sub D friendly and persistent close. Persistent close gives you a better idea of what the entire shape is going to look like. Okay, I'm going to back up here because I actually prefer to be in this window, and I'm going to use these other. I'm going to use this view and this view for reference, but I want to primarily be in this view. This is the view I want to work in. All right. Interpret curve. I'm going to start just a little bit above the middle of the crown, and you can see in these other views where that ends up. And so I want to pick a point that looks like it's roughly where you can see as I move my mouse and along this line horizontally, I can see where the point is going in the other views, and I want it to be right about where that point is starting to go down. So it's like right about here. And again, I could change this later to get it perfect, but I want to be right about here. So I'm going to click once to start that line, and then I'm just going to sort of work my way around at roughly that same distance around the upper edge of the crown. Be right about there. Okay, now I'm going to hit enter, and this is the shape we get. And we can see better what the shape looks like from this view, and we can see that we're roughly where we want to be. I can see one mistake here where we're actually higher up on this side and a little bit too low on this side. So that means this is a little too low, this is a little too high. So we need to pull this one up. Pull this one down. Yeah, pull that down, pull that up. The front and the back look pretty good, and we might want to adjust this little one here. All right, so it looks like in this area here, this needs to be pulled down. So if I select my curve, I can move these points slightly and then see where we're at. Yeah, it needs to be pulled down even more. Okay, that looks where we want to be, except this one is still a little bit low. So right in sort of the same spot, but on the other side, this is a little bit low. So we want to be pulling this up. Okay, curve point. Okay, that looks a little bit better. This one looks a little low here, so let's pull this up. Oop, nope. Okay, let's see what that looks like. Okay, yeah, that looks better. And then there's a little bit of something funky going on right there. I want to clean this up, and I think it's because this control point. Actually, what happens if we just delete that control point? Okay, and then we'll edit this control point to get it a little more uniform. Okay, that looks more uniform, and we're still roughly in the right spot. Okay. All right, so this is going to be the outside edge of our tipper. And you can see that the way we placed it is we placed it not exactly on the top, but roughly where that tangent starts to diverge. And we're doing that because we don't want to inadvertently create a crease line at the top that would be visible, or a witness line, as some people say. All right, next step. All right, now as the layer name indicates, what we're trying to do actually is create a cutting surface. So what we're going to do is we're going to take this curve and we're going to extrude it. Here, I'm going to deselect that first. We're going to extrude it. Extrude curve. It's going to ask us which curve we want to do. Okay, then we hit enter. Now it's going to ask us for a distance. Or actually, there's a couple of things here. First is we want to uncheck solid, but we do want to check both sides. The actual distance doesn't really matter much, but we want to be way above the cylinder. So you can see over here, we're above our cylinder blank. We just want to encompass the entire cylinder blank. And so we hit that, enter. Now we have a surface, a cutting surface. All right, and the thing we're going to cut is the cylinder block with our surface. So we're going to do a Boolean split. So you type in Boolean, it'll give you these options. Go down to Boolean split. All right, select the surfaces to split. This is what we're going to split. And we hit enter. And then select the cutting surface, which is the one we just created, that one. There's an option to delete the input, but we don't want to do that right now. But we hit enter, and we can see that what it's given us. Well, it's hard to tell. You can't see it, but what it has given us is that we have this line here. It's actually the outer edge of a different surface. All right. If we look at these other ones, there's actually another surface here. This is one that we don't want. We don't need that. This is the outside of what was cut. That's the outside. We don't need that. We can delete that. And we still have the inside. That was our original. That's the inside. We're going to select the inside part, and then we're going to move that to the tipper layer, because that is our actual tipper at this point. So move that to the tipper layer, and if I do single layer on, all right, this is what our tipper is going to look like. All right, looks pretty nice. And one thing to look for is you can see that the edge sort of does start to curl right here, but it's not curling so much that it would create a witness line when it's being pushing down on the top of that crown. Okay. All right, so this looks good. I will say here though that if you decided that you didn't like that, let's say we didn't like how far in or how far out this was going, like we felt like this needs to come in a little bit. If we felt that had needed to come in, then what we would do is we would take our cutting surface and we would do an offset of this cutting surface. I'll just do an example real quick. We won't do it here, but we would do an offset surface. Select that. you can see the arrows are pointing in, and then we would select a distance we want to come in. In fact, we'll just do that right now, just so you can see. And we don't want this to be a solid. You can see that it gives us another surface. Of course, not this time it's on the tipper layer, but this surface could be used to cut the tipper. All right, but we don't need that, but that's only just in case you want to come inside more without having to redo the entire process. Okay. All right, let's go to the next step. All right, the next step, as we look at our layer here, is we're going to add these tipper holes. I'm going to turn this on, and you can see what it does is it puts holes that are very similar to what we had on our crown. So these holes actually line up here. So this is a way of registering in your tooling, a way of registering the crown to the tipper, or rather maybe the tipper to the crown. If you don't have these tooling holes and you don't have something for them to go into, then what ends up happening is that this tipper could be off in the X and Y, or it could be twisted a little bit. That's going to make the top of the crown look off. So it's going to look asymmetric. So these extra holes here are going to have corresponding pegs in the frame, so that when you're doing an inverted crown on your brim form, this will be located in the exact correct spot relative to the brim, and the crown itself is centered on the brim, and that gives you like a much cleaner outcome. All right, but we need to put those holes there, and so what we'll do is, similar to how we did this on the crown, we're going to do a Boolean difference, and we'll type that in, Boolean difference. Actually, let's escape out of that. What we want to do first is we want to make this our active layer, tipper with holes, and I'll turn these other layers on. Tipper with holes is going to be our active layer. We're going to do a Boolean difference, subtract from is our tipper form, and subtract with, we want to select each of these holes, the blue. Then we hit enter. You notice we don't have delete input here. Hit enter. Now this is still on the tipper layer, but you notice that we have two objects here. We have the original poly surface and we have a new poly surface. We're going to move the new one to the tipper with holes layer. And we'll make that active and turn everything else off. All right, so this is the tipper that we actually want to print. Okay, and like we did for the crown form, we're going to select this, and then we're going to do, let's see, export. Here we can choose our name, and we want an STL. We don't need the textures. This is the same process we did for the crown, but in this case we're going to name this we're going to put in here also, this is the tipper. STL. Okay. Export, same options. We were in millimeters. We want this to be ASCII. All right. Okay, I'm going to open that up in MeshLab so we can take a look at it. Okay, I've opened our tipper in Mesh Lab, and we can rotate it around. It looks clean. There's no holes in it. It's we would have gotten an error if it weren't watertight, because it wouldn't be printable if it's not watertight. So this is printable, ready to go. Now for comparison, I also opened the original crown. This is the crown, and this is what the tipper looks like when it's on top of the crown. And you can see this gap here. That's intentional. That's a 1/10 of an inch gap that allows for the felt. It accommodates the felt there. And you can see like a 1/10 of an inch gap. That makes it just slightly more accurate when we count for that thickness. All right, so that all looks good. So at this point, we could take our STL and then send that to the 3D printer, and then we'll do a print of that, and then see how the two match up. All right, next step. Okay, we're in our program where we prep for printing on the Bamboo Lab 3D printer. Okay, we're going to import and you can see I've moved our STL to a file folder called Tippers. This is going to be on GitHub as well for people who want to just grab it directly. All right, you notice it's facing down. That was the orientation in which we created it, but we actually want this flat piece to be on the bottom. So we go lay on face, and we choose that. That puts it in the right orientation for printing. That looks good. We do need support for this, and we're going to do tree support. The quality is just standard. We hit slice, and then let's take a look at what that slice looks like. You see our tree support there. We'll hit print. This is a wood colored PLA, and looks like it'll be a 3-hour print at 150 grams. And it's a relatively new spool, 1,000 grams, so that should be plenty. We shouldn't have a problem with that one. All right, sending to the printer. All right, now we're in the device view, and this is just warming up right now, but I will come back like when we're about halfway, so you can see what it's doing. Okay, you can see here that we're about halfway through. This is a live view inside the printer. You could also probably hear in the background the printer running. We can see here we're past the 1/2 inch where our tooling holes were. So we're basically, all we're seeing right here is the internal honeycomb structure. All right, so I'm gonna let that go another 1.5 hours, and then when we pull it out, we'll demonstrate the result and then how it fits in with the existing crown that we already made. All right, that's up next. Okay, so the 3D printing process has been finished. This is our tipper. We can see that it's got the tooling holes for the pins, and when we place this in here, let's check. Yeah, so it fits fairly snug. We know that there's a little bit of a gap there to account for the felt. And in theory, it should be the same height as this, and that way that the tooling for the brim forms should all or the brim frame should all be the same. All right, so that's going to be it for this video. I'm probably going to sand this down and then give it a coating of shellac to waterproof it. In the next video, we're going to talk about how to extend this system to create the custom forms by blending different shapes together. All right, so stay tuned for the next video, and thank you for watching.